So today you guys got a new packet. It is Unit 1, Lesson 14. So in Unit 1, it suggested skipping these lessons. However, angles might benefit you when you take your SBAC test. So we are going back over them. So we're going to explore some alternate, which means opposite, interior, inside, angles. So find the measure of JGH. So the angle that goes from here to here. Well, if we know this is 30, and if we take half the line, angles on a straight line are 180. So we have 180 minus 30, which is 50. Sorry, 150. 180 minus 30. 0, 5, 1. 150 degrees. Find and label a second 30-degree angle in the diagram. We have two intersecting lines. Line IJ is intersecting with line FH. Intersecting lines are create vertical angles, which states that this angle and this angle are congruent. Congruent means they are the same measure. So if this is 30, this is 30 degrees. Find and label an angle congruent, so the same, as angle JGH. So this angle we found. So that means angle FGI, from F to I, and that is 150 degrees. It created a vertical angle, which means those two angles are congruent. They are the same measure. Next, cutting parallel lines with transversals. Line AC, so this line, and DF are parallel. They are never going to touch. They will never intersect. They will never cross. They are cut by transversal HJ, so this line right here. With your partner, find the 7 unknown angle measures in the diagram. We're going to label these. 1, 2, 3, 4, 5, 6, 7. And off to the side, 1, 2, 3, 4, 5, 6, 7. So on the first page, we talked about vertical angles and how they were the same. So if I were to cover up this half, we have two intersecting lines, and we determined that if they are intersecting, it creates vertical angles, and these two angle measures are the same. So if this is 63, 2 would be 63. We also determined that when we cover up part of it, from here to here is 180 degrees. So we need to find that difference for our missing angle. So we would have 180 minus 63 degrees. We need to borrow 711, 117. So angle of measure 1 is 117 degrees. Well, we created vertical angles, so that means if this is something, these two are congruent. They are vertical angles with the same measure. But now we need to work with our transversal. How do we find these angles? We're talking about alternate interior angles. And I believe it did say why some angles are always equal. Alternate interior angles are always equal. So alternate means opposite side, and interior. Well, this is like the inside of my two parallel lines. This would be the outside, all over here. So opposite interior angle. So I went to the opposite corner. So this one right here. So this is 63. This would be 63. That's 5. If we were to cut them out, we would see that they would match up. If we were to use patty paper, we'd see that they're the same. Can we see it over this? We can. So here is this angle. Let's see. We are going to turn it so it matches up with the vertex, and those are equal. Okay, so that was 5. The other alternate interior is 3, and the opposite side would be 4. If 3 is 117, 4 is 117. So we know this is 117, and this was 63. And then we go with our vertical angles. So if we cover up this bottom half, these are vertical angles. They are on opposite sides of each other. That means they are congruent. So if 4 is 117, 6 would be 117. And then 7, if 5 is 63 degrees, 7 would be 63 degrees. What do you notice about the angles in vertex B and the angles in vertex E? Well, all their angle measures are the same. So all the corresponding, I guess, angles, because corresponding would be on the same spot on the different line. So if we have them this way, if I'm looking at this spot right here on this line, I would then look at this spot on this side. They're on the same spot on different lines, corresponding. So the angle measures are equal. Using what you noticed in this one, find the measures of the 4 angles around point B in the second diagram. Lines AC and DF are parallel. So in order for all of this to be true, these 2 lines have to be parallel, because that makes their angle measures the same, because they're running along the same planes. So we need to determine what are all of these angles. So we have 1, 2, 3, 4. 1, 2, 3, 4. If this one is 34 degrees, and we were to draw it, hopefully you guys can see the lines as good as I can. Does this help? I don't think so. So we know that this is 34 degrees. I'm just going to translate it down so that E and B overlap. And my lines overlap the original line. So that means 1 is 34 degrees. 1 and 3 are vertical angles, so their angle measures are the same. 1 and 2, if I'm only looking at those 2, are supplementary angles, meaning their angles add up to 180. If we know 1, in order to find the difference, we need to subtract. So 180 minus 34, I'm going to borrow. So 10 minus 4 is 6, 7 minus 3 is 4, and then 1. So 2 is 146. If these 2 are vertical angles, these 2 are vertical angles. So angle measure 4 is also 146 degrees. Number 4. The next diagram resembles the first one. So it's similar to the first one, but the lines form slightly different angles. With your partner, find the 6 unknown angles with vertices at points B and E. So they're slightly different. We have D and E goes like this. A and C goes like this. Eventually, they're going to run into each other. They're going to intersect. So these lines are not parallel. We know about vertical angles, and we know vertical angles have the same measure. So these ones I'm not going to number because I feel like there's enough room. So vertical angles for here would make this 63 degrees. and vertical angle here would make this 108 degrees. If they were parallel, we could use alternate interior angles because they have equal angles. But if I put 63 here, I have 108 plus 63, which is 8, 9, 10, 11, 171, which isn't a true statement. It does not work. So we need to figure out the difference using supplementary angles. So if this whole angle is 180 degrees, we need to figure out what is that difference. So we get 117. So that these two are 117. And we can do the same thing here. If these are supplementary angles, I'm going to do it that way. They also equal 180, so we need to figure out the difference. 180 minus 108. So we get 172, just 72. What do you notice about the angles in this diagram compared to the earlier diagram? Well, the angles are different. Because lines AC and DF are not parallel. How are they the same? Well, they are the same because, here it is, the transversal went through the same spot on line AC. So this one is what was the same. So they are titled angle ABE is the same in both. Angle ABE is 63 degrees in both diagrams. On to the next page. Are you ready for more? There's a couple ways we can do this. Lines L and M are parallel, and they're cut by two transversals. We have one, we have two, which intersect at line L at the same point. Two angles are marked, these two. Find measure of x. So some stuff we know is that this is 55 degrees. These are vertical, so this is 55 degrees. Angles in a triangle equal 180 degrees. We could also go with, if this is 55 degrees, this is 55 degrees because they are corresponding angles. They have the same measure. And this is 180 degrees. And then we'd be able to find our x. So we're going to do 180 minus 60 minus 55. So 60 and 55 is 115. I'm just going to put it as 1. So I have 7. 10 minus 5 is 5. 7 minus 1 is 6. So x equals 65 degrees. This one I copied incorrectly. So we have this part and then this bottom part goes to it. Line L and K are parallel and T is a transversal. M is the midpoint of segment PQ. So M is halfway between P and Q. In this picture, line L and K are no longer parallel M is still the midpoint of segment PQ. Does your argument in the earlier problem apply to the situation? I must have missed something else. So, because there must be another question somewhere that I didn't get. I'm not sure. Cool down. The diagram shows two parallel lines, line 1, line 2, cut by a transversal, line T. One angle measure is shown. Find the values of A, B, C, D, E, F, G. We can do all that. We know that these are vertical, so they are the same measure, 54. We know that B and D are alternate interior angles. Remember, this is the inside of my two parallel lines, and this is on the opposite side. So opposite inside angle. So here we go. So that means D is 54 degrees. And we know that these two are vertical angles, which means they have the same measure. So this is 54 degrees. Now we have to figure out what one of the other missing angles is. So if we looked at just this, we have a straight line from angle E and angle F. Remember, a straight line has a total measure of 180 degrees. So to find the missing one, we need that difference. So 180 minus 54. I had to borrow from an 8, so 10 minus 4 is 6. 7 minus 5 is 2. 1 minus nothing is 1. So all of our other angles are 126. Part 2 of the other one that we crossed off, we're just going to cross that one off as well. On to the practice problems. You do have to do all of them because I say so. So we are given angle CBD. It is 50 degrees. I have two lines that are intersecting, creating vertical angles. So these two are the same. That means angle ABE, angle ABE is 50 degrees. We need to figure out what one of these two. This is a straight line right here, CE. So that means these two angles are supplementary and add up to 180. So the difference to figure out what our missing angle is would be 130 degrees. So this is 130, and this is angle ABC. These are vertical, so that means EBD is also 130 degrees. Number 2, lines K and L, line L, are parallel. The angle of measure ABC is not 119, 19 degrees. Explain why the measure of angle ECF is also 19 degrees. If you get stuck, consider moving, translating line L, moving B to C. So explain why we know it is 19 degrees. Well, they are corresponding angles. And those have the same measure. But also, if we did translate line L to go over, so B map to C, their angles would map. And remember, mapping means they lie over each other and that they're the same thing. And that goes with this one as well. What is the measure of angle BCD? BCD. So this angle. Well, these two are vertical, so it'd be 19 degrees. Because angle ECF and the one we just measured, BCD, vertical angles. Vertical angles. Question 3. The diagram below shows 3 lines with some marked angles. Find the missing measures. These 2 lines are not parallel, so you have to look at them as 2 different problems. So if we're looking at just this one, we have 2 intersecting lines, which creates vertical angles. So if this is 70, the one across from it would also be 70. And then it creates a straight angle, which is 180 degrees, or a supplementary angle, where this angle plus this angle equals 180. The difference between the two would be 110. If you didn't know that, it's 80 minus 70, which gives you 110. Which makes these two equal because they are vertical angles. Next set. This line. Again, we're stuck with vertical angles, which means they are the same measure. And then we need to figure out what is that difference to figure out our straight angle, which is a straight line. So we have 180 minus our known angle of 53. So 10 minus 3 is 7. 7 minus 5 is 2. 1 minus nothing is 1. Which gives us 120. 127. So they are the same measure as well. Question 4. This is a review from a long time ago. So the 2 figures are scaled copies of each other. Scaled copies, remember, also means there was a dilation. Dilation means your image gets smaller or bigger, or if it's a direct copy, has a dilation of 1, so it stays the same size. What are some ways you can tell they are scaled copies? Their angle measures are the same. So right now you don't have a protractor or anything to measure. It's kind of hard to measure it on here, but I can measure this angle, and if I put it right over the scale copy, it maps to it. I could also measure this angle at, not very straight, at point A, and I can see that it maps to P. It's kind of hard to see through here. If I had patty paper, it'd make it easier. So their angle measures stay the same. Measures are equal. What is the scale factor that takes figure 1 to figure 2? So going from here to here. I'm going to measure the distance between A and C. That is 2. So it goes from 2, and P is 1, 2, 3, 4, 5, 6. So how many times larger does it get? Well, I got 3 times larger. You can also measure this because it goes directly through. So our slope would be up 1 over 1, which means I have to do it 3 times. 1, 2, 3. And that still got me to Q. So this is times 3. What is the scale factor going from 2 to 1? So we still went 6 to 2. Remember, scale factor, you don't divide. If we're thinking of dividing, it's dividing by 3. Because it got 3 times smaller. The opposite of dividing by 3 is to multiply by 1/3. Or the same, not the opposite. The same as dividing by 3 is multiplying by 1/3. So our scale factor would be multiplying by 1/3. And that brings us to the lesson for tomorrow, which will be done tomorrow.